Mark makes a cylinder-shaped container by using a piece of rectangular sheet metal as shown in the figure below. What is the volume of this container in terms of pi? Alright, well, you can see that here's this piece of rectangular sheet metal, and we're given one of the dimensions. And so we're going to cut out a couple of circles, and then we'll roll this other piece of sheet metal into a cylinder and put the top and bottom on. Okay, so it's going to end up looking like, okay, we have a top, we have a bottom, and then we roll the other piece of sheet metal around and attach the top and the bottom. So that's the rectangular piece of sheet metal. We'll just wrap right around there. Okay. And the volume of this cylinder is just going to be the base area. So the base area, and that's just pi r squared because it's a circle, right? So pi r squared times the height, okay? So we need to figure out, in order to figure out the base area, we need the radius, and then we'll also need the height. So, well, let's just take these circles here and draw in some radii, okay? So let's say this is the radius r, and you know, we could draw these radii any place, right? Because the circle is just all the points that are a distance of radius r from a center, right? So the distance is a constant from the center. So we can draw all kinds of radii in here, alright? It's all going to be the same radius, no matter where we choose our radius. Okay, so I'm just going to choose it like that. And then you can see, from top to bottom of this piece of sheet metal has to be 4r. Okay? Just because, you know, we've got two circles, and so we have 4 radii from the top to the bottom. And this piece of sheet metal has to wrap around the whole circumference of the circle. So, and the circumference of the circle is just 2 pi r, okay? And you can see that's not going to work if you use this edge, because this is 4r, not 2 pi r. This is going to be closer to, you know, 6.28. And this is only times r, and this is 4 times r. So this distance here has to be across here 2 pi r. So this distance here has to be 2 pi r. Okay, and the height, this has to be the height, 4r. So so we're going to take it and wrap it this way. Okay, we can't wrap it. It won't go all the way around if we try to wrap it this way. Okay, so this is going to be where it attaches along this edge. We'll attach the top and we'll attach the bottom. There and there. Alright, well, the circumference is 2 pi r. And you can see that, okay, so if we know this distance is 2 pi r, and then we have here's r and here's r, so the total distance has to be r plus 2 pi r, which is 2r plus 2 pi r. Okay, the total distance across here. So here's r, and 2 pi r. Just add that all up, and that should be equal to the distance that we're given, which is 4 pi plus 4. 4 pi plus 4. Okay. Now you can see we have an r and an r. We have a factor of r in both of these terms. So we can actually factor that out, and we end up with 2 plus 2 pi times r, and that has to be equal to essentially 4 plus 4 pi, right? So you can see the r has to be 2 in order for that to work out. So now we know r, and now that's basically all we need to know, because we determined that the height has to be 4r. So the height is equal to 8. Okay, 4 times 2, 8. That gives us the height, and this pi r squared, which is the base area, is just going to be 4 pi. Okay, and the volume is equal to the base area times the height. Alright, and that's true for any right prism. Okay. Okay, that doesn't really matter what the shape of the base is. It could be it could be a triangular prism like this. It's also, if we can find the area of the base and take it times the height, then we'll get it. And that's as long as the top and bottom are congruent shapes, and as long as the sides make a right angle with the top and the bottom. Okay, so we call that a right prism. So a cylinder is basically a right prism, okay, but with circular top and bottom. So just remember base area times height. And base area we said was 4 pi. This is the volume. And the height is 8. So we end up with 32 pi. And that's our volume.